right, this is BCA-101. We listened to a little bit of a podcast, actually, from public radio about big data. It talks about how that's being used, and it was interesting. And then we talked about the algorithms or the software that allow us to pull out of that data valuable information that allows us to make decisions. Okay, so we used WebAdvisor as an example, and we can use a browser to look at it. Then we also talked a little bit about ISPs and what information should ISPs track on their users and if they should at all. Okay, then we talked about developing an information system. So I'll give an abbreviated report here. We talk about life cycles of everything. You know, we create things, we use them, and then eventually they wear out. Whether we're talking about humans, a good hunting dog, a car, I mean, it could be all kinds of things. We'll go through life cycles. Information systems go through life cycles. Like we're currently using WebAdvisor. We used to use something here at NIAC called Poise. It used to do some of the things that we needed to do, but it didn't allow us to have very good communication through a web browser for students to register for classes and see their grades and all that stuff. So we had, as an example, a problem. And so you investigate the problem, make sure you understand what the problem may be. Mark Zuckerberg at Facebook decided he had a problem. Relationships. How do you know if somebody's in a relationship? So he created that relationship tab and added it to his software. Maybe not a great example, but landing airplanes efficiently, airports, air traffic control software, subway software, manage subways and all in like Washington, D.C. or whatever, complex things that we use software to help us manage that. Okay? So once you understand the problem, the next thing is you analyze it. Okay? You understand how things currently work, what data goes to who, what things need to occur, so you do a complete analysis. You got to make sure you understand what you're working with before you start creating a design. Here's where we start talking about building a new house. Why would you build a new house? Well, you must have some problem. So somebody said, your house has mold. We had a flood, water in the house has mold, you can't live in it anymore, so you need a new place to live. So you analyze what you got, okay? You got 4 kids, you got X amount of income, et cetera, et cetera, et cetera. You got to understand how things currently work. If it's an information system, data flow, how it works, and so forth. So you do an analysis. Then you decide, yeah, we can build a house, then you can design it based on all this analysis, how many bedrooms you need, and so forth. Information system, the same thing. You start creating data flow diagrams, which information goes to who, what things are going to be done. For example, WebAdvisor, when they designed that, they had to figure out how you could put classes in there, how you keep track of faculty, how you can keep track of students, how you can keep track of whether they paid or not, how many credits they're taking, their GPAs, how do all those things. How are they going to be able to register, what things they need to register from a web browser, checking their grades from a web browser, how we can do a retention alert, lets people know students aren't doing well or not attending class, and so forth. So we go through all this design. That stands for flowcharts and pseudocode. We talk a little bit more about that programming on Monday. Then once you're pretty sure you have the design down, like the blueprints to a house, then you can do the development. You actually have to buy the ground and dig a hole and start doing it. Information systems, you can look at buying packages, you can look at programming it all yourself, or some mix in between. Okay? Developing the programming yourself, writing your own code or paying somebody is extremely expensive. Buying a package could be much cheaper. But if you buy a package, that's a package then everybody's using. For the college, WebAdvisor, that made sense to buy a package that we could adjust and change because we don't really need to build a large advantage in how we manage that information. Plus, then we can communicate with other universities. But some places like Walmart and other stores, they'll write their own programs for their information system in order to build an advantage, or their system's so unique they can't find a package for it. So there can be a number of reasons why you would spend more money and develop the code. Some places, after they develop the code, they sell it, and some places don't sell it because they don't want their competitors to have it. So you buy computers, you test, you get the whole thing working, and then you implement it. You might be able to implement it in one store or one location and see how it works. Or sometimes you might phase it in, put in different parts, make sure they're working, and then add another part. In some cases, you have no choice but to just convert it completely over, a direct cut over. Now, you've implemented it. Now you need to make sure you evaluate it and see that you're getting your benefits out of it, and then you have to figure out how to maintain it. Make sure it keeps working appropriately. So it kind of is like a big cycle. You go back up, and you go back up here, and you investigate the problem and see that you have it solved by your system. And if you see some glitches that aren't working, you analyze those, figure out what they exactly are and what you need to do. Then you design a solution to that, some kind of a patch. You develop it, you write the code for the patch, and then you implement the patch. You do an update. And then you evaluate again and see if it's working. So this is a top-down analysis method, or a top-down design of an information system. And then I'll finish up today talking about a bottom-up. There's lots of things we do that's bottom-up. Bottom-up is you actually start building like a pilot or a test phase almost right away. You look at the investigation, the analysis, and the design briefly, and then you start development right away before you really know exactly everything you're going to put in it. So it's almost like bottom-up. And then you can get a pilot running and see how it works. And then you go back up and readjust the design and analysis as you go. I used the example of building a treehouse. I bought the lumber first rather than any design and just started building and created it as I went. Technology-wise, probably doing a PowerPoint. Most people design it on the go. A lot of spreadsheet stuff is done bottom up. Prototyping. You start designing your spreadsheet, then adjust it as you need be. That works well for some cases, not others. If you're designing software to help do heart surgery, you probably need to do top-down because you can't afford to have any mistakes in it. If you're doing bottom-up and something is wrong, you might have to scrap it and start over. Like if my design for my treehouse was not safe, I might have had to tear it down and start over. In some cases, you can't do that, like if you're designing software to land airplanes, okay? And lots of other things like that. All right, well, that is it for today.